We got circumference of a circle is the perimeter, fancy word for the perimeter of a circle. So all around the outside of a circle is circumference. And we can represent that as 2 times pi, which is that relationship between the diameter and the circumference. That's what pi comes from. So 2 pi r, or, which makes sense, pi times the diameter, because the diameter is 2 radii. A sector is when you get something like this. It's a portion of a circle. So you've got a radius, which is the same length as another radius, and then you got this. And our old friend theta is back, right? Theta represents an angle. How many degrees are there in a circle? 360. So we can use that to figure out just how long that arc of that sector of the circle is by using that as a fraction. We have a couple special words though. A semicircle, semi means half, and a quarter of a circle is a quadrant. So those are words that might come up in our future. So this looks really fancy, this perimeter of a sector. The perimeter is the 2 radii, so this and that again. And then in order to get this, we're going to use the circumference 2 pi r, but we don't want the whole thing. We only want the fraction of it. So we're going to use whatever that theta number is out of 360. So it's a fraction. If you had a quarter circle, that fraction would be 270 over 360, which is just 3/4. So we'll do one of those. Symbol for pi can be used to write exact answers. Remember, when you want an exact answer, you're going to leave the surd there. So pi is irrational, like some of your teachers, myself included, which means that it never stops. So if we keep it as the symbol pi, it is the exact answer. That's what they're looking for. So the circumference of this circle, because we have a radius, 2 pi r, 2 times pi times 3, which is 6 pi. And when we get our calculator out, it will come up to something that's 18.8 something something something, but we're going to round that to 8.5 because it told us to round to 2 decimal places. That's where that comes from. So that's just straight up circumference. 2 times pi times the radius. This one is a sector, and the perimeter of a sector includes the 2 radii. So that's this one and that one. And then to that, we're going to add the rest of it. So just let me write this first. We know the full circumference is 2 times pi times the radius, but this isn't a whole circumference. This is 100 360ths of a whole thing. Where did I get 100 from? There's our angle of 100, and we know that a full rotation all the way around a circle is going to be 360. So from there's a couple ways we can do it. I know that 14 is going to be part of this because 7 plus another 7, the 2 radii have to be the same, is going to give me 14. To that, I'm going to add this. So I can think of this as a fraction and I can reduce it, or I can just chuck it into my calculator. So I'll show you the fraction first. If I did 100 over 360 times 2 pi r, I'll work out that that actually equals, if I add 100 times 2 times pi times the radius of 7, that will give me 35 pi over 9 once I reduce it. But I'm going to show you now how to do it on the calculator because I think it's even a little bit easier. If you have this sharp calculator, it was 100, and I'm going to use the ABC button, 360. So now I've got, it's just how it is. It's 100 360ths times, this is the formula, 2 times, where's my pi button, times my radius of 7. That gives me this super fancy number. So once again, I'm going to do that one more time. I had 100 over 360, so I use 100 and I use the ABC button. You could do 100 divide 360 and get the same answer. And multiply that by 2, and multiply that by pi, and multiply that by 7, because that's our formula, and that gives us 12.21, etc. Is that the final answer? Still need to add the 14 in there. So that gives us 26.217, which rounds up to 26.22. So forgive me not writing that in there. And this is where we would put in that it's meters. This one's given in meters. Right. Now, the exact circumference, remember, when we're looking for the exact circumference, we're going to leave pi in there. We're going to leave the pi symbol in there. So the circumference, again, is equal to 2 times pi times the radius, or 2 times pi times 4. So what's the answer? We can multiply in any order. 2 times 4 instead of 2 times pi. 4 times 2 is 8. We're done. That's all it is. So you just have to know when it says exact answer. Don't go through with that final computation because you're going to be rounding it. If it wants an exact answer, you got to give that. And in the textbook, if you're interested, it says these are centimeters. So that's a measurement, 8 pi centimeters. If you didn't have centimeters, you just say units or leave it the way that it is. How much of a circle do we have there in part B? Yeah, if you look at it, you can put 273/60ths. But if you can see that that's a 90-degree angle and work out that that's 3/4, then we're in good shape. So for this one, our perimeter is going to equal those 2 radii, which is this guy and that guy, plus 3/4, right? That's what's left of the circle, the segment, times 2 times pi times the radius. So that's, I'm going to jump ahead and do 2 times 2 is 4, plus 3/4 of 2 times pi times the radius of 2. And I'm going to put that over 1. Why am I doing that? Because I can multiply everything across the top and everything across the bottom. So then that leaves me, when I finish doing that, 4 plus, because I can cancel out those 4s, 3 pi. Because I made it into a fraction. Again, you can go on your calculator, 3 ABC4 times 2 pi 2, or this is 3 times 4 pi over 4. Because if I'm multiplying them together, and so now I can cancel out, those 4's, which gives me 4 plus 3 pi. And that's it. Because I can't add the 4 together and still have an exact answer. Once again, in the textbook, these are meters. So if you want to add in that they're meters and say they're meters, that's how that goes.